Hello everyone, my name's Amos Branch and I'll be the lecturer for the second part of the CVEN9892 course. This short video is to give you an introduction into the content of the second part of the course. In particular, an introduction to risk analysis and also decision analysis. The part 2 of the CVEN9892 course aims to introduce you to risk analysis, to help you understand some of the systematic approaches for chemical and microbial risk analysis, to show you some examples of where those management practices are used in the context of water and wastewater treatment, and also to demonstrate some techniques to help you make decisions when there are multiple criteria which you need to consider. Along with this short video, I've uploaded a paper on the quantitative definition of risk. This is from Volume 1, Issue Number 1 of the Risk Analysis Journal, and it's written by Stanley Kaplan and John Garrick. This important paper goes through the frameworks which are still used today for a large amount of all risk analysis. The first thing to consider when analysing risk is the set of triplets, the three questions which every single risk analysis procedure will need you to ask. The first is what can happen and what can go wrong. The second is how likely is that to happen? Can you put some numbers around, is it going to happen this year? Will it only happen once every 10 years? And then finally, if it does occur, if that event that you're analysing the risk for occurs, what are the consequences? What are the harm that can eventuate out of that event? It's important to start thinking about separating terms, and the Kaplan and Garrick journal article goes through this in some detail. For the purposes of the rest of this course, we'll define a hazard as a source of danger or harm, while a risk is the possibility of loss or injury resulting from that hazard if it were to occur, and also considering the likelihood of it occurring. Hazards can come in multiple forms. There can be the electrical energy in household outlets which could cause electrocution. They could be a speeding car which might hit you and cause physical injury. A pathogenic virus which might make you sick if you're infected with it. A meteorite which could come crashing into the earth and end life as we know it. Or a toxic chemical that if you're exposed to could have harmful impacts and effects on your health. The risk encompasses the impacts on health and the environment that could eventuate after being exposed to these hazards. Risk doesn't exist if exposure to a harmful substance or a hazard cannot or will not occur. In the equation presented from Kaplan and Garrick, risk can be expressed as equal to the hazard divided by the safeguards. The important observation that comes from this equation is that risk can never be zero. As long as a hazard is present, there will always be some risk, even if you have an infinite level of safeguards. Risk is also relative. Risk depends on what you know, what you don't know, and also the actions that you partake in. It's expressed as risk is relative to an observer. It's a subjective thing. It depends on who's looking. So in the example in Kaplan and Garrick, some people put a rattlesnake in a man's mailbox. He comes out to collect his mail. If you were to ask the people if there's a risk, they would certainly suggest that there was. However, the man has no idea because he doesn't know that a hazard exists. This same scenario can be translated to a variety of real-life situations and highlights the importance of always improving risk management and characterization data for new and upcoming hazards. Finally, a key concept is acceptable or tolerable risk. Going from the equation where risk is equal to a hazard divided by safeguards, it's important to note that it's hyperbolic. You can spend an infinite amount of money in terms of implementing safeguards, but you will never reach a zero risk value. What's important in engineering is to start to consider what is an appropriate level of risk management in terms of perhaps economic indicators or other decision criteria as well, noting that you'll never be able to completely control a risk to a zero level. Alright, I'd like to invite you to read the rest of that journal article by Kaplan and Garrick. I'm sure you'll learn a lot if you do, and I look forward to seeing you in the first lecture, which will be on chemical risk analysis.